Hey y'all, so in this video we're going to learn to compare numbers that are written in scientific notation. I have two numbers that I wrote down to start with, 6 and 8 tenths times 10 to the second power, and 4 and 5 tenths times 10 to the third power. And we're going to compare the size of these two numbers, which one's bigger and why. So I'm just going to start off by using what I know about scientific notation, and I'm going to put both these problems in standard form. Now, I know that I have 6.8 times 10 to the second. I see this second power tells me I'm going to move my place value 2 times. And this is a 10 to the positive second power, so I know that my number is going to get bigger. So I'm going to move my decimal in a direction that makes it bigger. That direction would be to the right. I'm going to move it 2 times to the right. So I know that this number is a total of 680. I'm going to do the same thing for this one. I have 4 and 5 tenths times 10 to the third. 10 to the third, I have a positive exponent, so I'm going to move my decimal point 3 times in a direction that makes my number larger. 1, 2, 3. Now it's pretty easy right now to compare the size of our numbers. 6 and 8 tenths times 10 squared is 680. 4 and 5 tenths times 10 to the third is 4,500. Obviously, this one is bigger. There are a few mistakes that students sometimes make when they do this. They see this 6.8 and they say, ooh, this is bigger than this, so this number has to be bigger. But that's not what's most important. This is what's going to tell you which number is larger for the most part. If these two are different, then this number will tell you which one is larger. We're multiplying this by 10 to the second power. This one is 10 to the third power. 10 to the third power is greater. It's 10 times greater than 10 to the second power. So anything raised times 10 to the third power is going to be bigger than anything times 10 to the second power. Let's do another example. And this time, let's do it with some negative numbers. So I have two numbers, 3 and 2 tenths times 10 to the negative third, and 4 and 5 tenths times 10 to the negative fourth power. Now I'm going to expand this as well so we can compare them. You might make a guess. Which do you think is going to be bigger? The top number or the bottom number? We'll see if your guess is right. 10 to the negative third power tells me that I'm going to multiply this in a direction that's going to make my number smaller. This negative exponent tells us that we're dividing by 10 3 times, and the more times that we divide by 10, the smaller our actual value becomes. So, the negative exponent tells me I need to move this decimal point 3 times in a direction that makes my number smaller. That direction would be to the left. 1, 2, 3. So 3 and 2 tenths times 10 to the negative third is 32 10,000ths, 0.0032. I'll do the same thing with this one. 4 and 5 tenths, my exponent is negative, which means I need to move my decimal 4 spots in a direction that's going to make my number smaller. And that's going to be to the left. 1, 2, 3, 4. We'll fill in our place values with 0. Oops, one more 0. Okay, now it's time to compare our two numbers. I'm going to just write our two numbers down here. I have this one here. Let me just move this one. I'm going to line up our decimal points so it's easy to compare. I have 0.00045, 0.0032. How I compare is I start at the decimal point. The ones values are the same. The tenths place value is the same. The hundredths place value is the same. Now I look to the thousandths place value. My top number has a value of 0. My bottom number has a value of 3. The first time I see, when I line up my decimals, the first time I see where there's two numbers that are not the same, so this was the same, these are different. That's where I evaluate which number is bigger. Which is bigger, my 0 or my 3? Well, 3 is bigger than 0, so that means this number, 0.0032, is larger than 0.00045. So if we go back to our original examples, the one that was raised to the negative third power is greater than the one that was raised to the negative fourth power. And if we think about a number line, this makes sense. I have a number line, -1, -2, -3, -4. I said the one raised to the negative third power was greater. That makes sense. -3 is farther to the right on the number line. It is farther towards all the numbers that are getting greater. The more we move to the right, the bigger our numbers. -4 is farther to the left. So even though 4 looks bigger than 3, -3 is bigger than -4. Let's try one more. Let's do 6.2 times 10 to the -5th. And, oh, I don't know if you can see that. Let me move it down a second. Times 10 to the -5th and 2.8 times 10 to the -3rd. We'll compare these. Which one do you think is bigger? The one raised to the -5th or the one raised to the -3rd? Well, let's try it out. I know that I can move my decimal on this one. I'm going to move it in a direction that makes it smaller because my exponent is negative. And I'm going to move my decimal 5 times. 1, 2, 3, 4, 5. On this one, again, I have a negative exponent. So I'm going to move my decimal point in a direction that makes my value smaller. I'm going to move it 3 times. 1, 2, 3. Now I'm going to compare these two numbers. I'll do that right over here. My first number at the top is 0.00062. And this one, I'm going to make sure I'm lining up my decimal points when I compare the size. Cool. We'll start from the left and move to the right. The same, the same. Oh, these two numbers are different. Which is greater, 0 or 2? Well, 2 is greater. So that means this value is greater. Again, -3 is greater than -5 if you look at it on a number line. It is farther to the right on a number line, which means that this value is going to be greater. You have the next problems to do. You have 10 different numbers, and I want you to rank them from least to greatest. The smallest number, you're going to put a 1 in the box. The biggest number, you're going to put a 10 in the box. When you're finished with that, you have a backside to do for review problems. Good luck.